morning. This is Kasturi Day. Today I'm going to start a new chapter on physics according to ICSE syllabus class 8, that is physical quantities and measurement. Okay, so first we come to density. Okay, so each body we know has a certain mass and a definite volume. Okay, so the volume occupied by a body increases if its mass is increased. Okay, like that, if the mass of a body increases on increasing its volume, further equal masses of different substances at different volumes. Okay, so different substances but having equal masses, but they have different volumes. For example, volume of cotton is much larger than the volume of an equal mass of lead. Okay, it's because the particles of lead are closely packed, while those of the cotton, they are very loosely packed, and that's why lead is denser than the cotton. So the mass is same, but the volume of cotton, the different substances, that is the different substances having the mass same, but they have different volumes. Then equal volumes of different substances have different masses. Okay, first one I told you that equal masses of different substances have different volumes. But here, next one I'm telling you that equal volumes of different substances have different masses. Volume is equal, but substances are different, so their masses will be different. For example, mass of iron is much more than the mass of equal volume of wood. See, equal volume of iron is taken, certain volume of iron is taken, and equal volume of wood is taken. But we see as iron and wood are two different substances, we see that their volumes are different. I mean, their masses are different. Sorry, the masses are different. Volumes are equal, but the masses are different. It's because the particles of iron are more closely packed than those of wood. That's why volume is same, but their masses differ. Why this happens? Let's explain. Equal volumes of different substances have different masses, or equal masses of different surfaces have different volumes. Okay, that is the density. Okay, so what happens? Equal volumes of different substances have different masses, or you can say equal masses of different substances have different volumes. That is density. So what is density? Density is the mass per unit volume of a substance. Okay, if for say m is the mass of an object and v is the volume of the volume of that substance and density is d, capital D, then the volume v has a mass m. Okay, and so unit volume has a mass m by v. Therefore, mass of unit volume is equal to d, capital D. So d is equal to m by v. Understood? That is, if m is the mass, let's say that we take a substance whose mass is m and volume is capital V and density is d. So we see that the volume V of that substance has a mass what? M. And unit volume, okay, unit volume is what? Unit volume of that mass will be m by V, and mass of unit volume will be capital D. So D is equal to m by V. Next we come to units of density. Units of density is equal to unit of mass by unit of volume. So what is unit of mass? In SI system, mass unit is kilogram and unit of volume is cubic meter or meter cube. So in SI system, the density unit is kg per meter cube. You can write kg by meter cube, or you can say kg m to the power minus 3. Okay. In CGS system, unit of mass is gram and unit of volume is centimeter cube, cubic centimeter or centimeter cube. So in CGS unit, the density unit will be gram per centimeter cube, or you can write G by cm whole cube, or you can write GCM to the power minus 3. Now, what is the relation between the SI unit and the CGS unit of the density? Okay, so 1 kg per meter cube is equal to 1 kg by 1 meter cube, and that is equal to, if you convert into grams, if you convert into CGS unit, that is 1 kg is equivalent to 1000 grams, and 1 meter cube is equivalent to 100 centimeter cube. Okay, so if you divide it, it will give 1 by 1000 grams per centimeter cube, or you can say 1 kg per meter cube is equal to 10 to the power minus 3 grams per centimeter cube. Okay, it's not 3, but it is 10 to the power minus 3 grams per centimeter cube. You can see 1 by 1000, so it is 1 by 10 to the power minus 3. Okay, and 1 gram per centimeter cube, or you can say 1 gram per centimeter cube is equal to 10 to the power 3 kg per meter cube. Here it will be 10 to the power 3, that is 1000 kg per meter cube. 10 to the power 3 cube means 10 cubes is equal to will be equal to 10 into 10 into 10, that is 1000 kg per meter cube, or you can say 1 kg per meter cube is equal to 1 by 1000, that is 10 to the power minus 3 grams per centimeter cube. So, for a note, it is written, the density of a substance does not change with any change in its shape or size. If you change the shape or the size of a substance, that does not change the density of the substance. Almost all substances expand on heating and contract on cooling, but the mass does not change. If you heat a substance or cool a substance, that does not change its mass. So density of a substance decreases with the increase in, it increases or decreases with the increase or decrease in temperature. It decreases with the increase in temperature and increases with the decrease in temperature. Okay, it increases or decreases with the temperature. Okay, and density, because its volume changes, not because of its mass. Okay, so exception is water contracts on heating from 0 degrees centigrade to 4 degrees centigrade. That's an exception for water, for any substance, that is water contracts on heating from 0 to 4 and expands on heating above 4. Vice versa, when it is cooled till 4 degrees centigrade, it decreases, volume decreases, but from 4 to 0 it expands. Okay, so the density of water increases from 0 to 4 degrees centigrade, then decreases above 4 degrees centigrade. The density of water is maximum at 4 degrees centigrade, that is 1000 kg per meter cube. Next we come to determination of density of a regular solid. So for this, we need to measure a substance, a solid substance, okay, with a physical balance or beam balance, you can say, which is measured as M. Say it's an M grams or M kg. Okay, we take it as M. Okay, and to find its volume, we take the length, breadth, and height. Or if it is a cuboid, if it is a cube, then we take a side cube, and if it's a sphere, we make it that we calculate it as 4 by 3 pi r cube, whereas pi is equal to 3.14. The value of pi is 3.14. Here this gives us the volume of the regular solid by this formula. Then we divide mass by volume. Okay, that gives the density of the regular solid. The side of the cube or cuboid is L into B into H of a cuboid, and for cube it is side cube, that is. Okay, or radius of the sphere or radius and the height of a cylinder can be measured with the use of a meter ruler. If you with a meter ruler, the side of the cube or the cuboid, that is length, breadth and height, for the radius of the sphere or radius and height of a cylinder, that can all be measured by meter ruler. Okay. Then for measuring the vessels, for measuring their density, we use vessels. For measuring the volume, rather, for density, it's for measuring, for the finding out the density, we need to first measure the volume. If it is a liquid, we use a measuring volume, measuring cylinder, measuring beaker, or a eureka can. See from the picture, first one is a measuring cylinder, second one is a measuring beaker, and the third one is a eureka can. These vessels are used for measuring the volume. Okay, so I'll stop here. I'll continue with the next in the next video, the rest of the question chapters. Okay, text video. Okay, so please go through this. If you have any doubt, please to write in the comment box, and hope you are liking the videos and they are helping you a lot. So if you like it, press the like button, share with your friends so that they can also be benefited from this videos. Okay, and if you are a new viewer to my channel or not subscribed yet, please to subscribe to get the notification of my next video. Thank you.